So let's start. Number 10. Earth landed in the right spot and stayed there long enough. When scientists talk about the habitable zone, the phrase can sound a little too forgiving, like every star comes with a quiet little neighborhood where life can just move in and settle down. In reality, it is more like a very narrow band where temperatures stay just right for liquid water to exist on the surface over long stretches of time. Move a little farther in, and the oceans can evaporate. Move a little farther out, and the water gets locked away as ice. Earth did not just brush the edge of that zone. It sits in almost the best possible position, warm enough for water to exist, stable enough that the climate does not turn into a cosmic dice roll. But being at the right distance is still not enough by itself. A planet can pass through the habitable zone like a guest drifting through a party, then disappear before it even gets the chance to sit down. What makes Earth different is that it also held onto a nearly circular stable orbit for an extremely long time. That may not sound dramatic, but for early life, it is almost the entire story. The first chemical reactions do not work well when a planet keeps swinging back and forth between an oven and a freezer. They need time repetition and an environment calm enough to fail, try again, and slowly grow more complex. As astronomers have studied planets beyond our solar system, they have found plenty of worlds that sit near the habitable zone, but close enough is not always enough. Many planets are tidally locked, with one side always facing their star, while the other remains trapped in permanent night. Others have orbits so stretched out that their climate seems to change personality every year. Earth did not have to deal with that kind of instability. It has a relatively gentle star in orbit with very little drama and a span of time long enough for life not only to appear, but to evolve into something capable of sitting here and asking why everything lined up so perfectly. Number 9. The sun is just calm enough to support life. When people talk about how lucky Earth is, they usually point to the oceans, the atmosphere, or the moon and forget about the thing sitting at the center of this system and quietly deciding the whole game. Not every star is suited to host a living planet. Some stars are too massive, burn bright, and die young, like throwing a party and cutting the power before anyone really settles in. Others are smaller and can live much longer, but they are erratic, constantly blasting out flares and intense radiation enough to make sure a nearby planet never gets the quiet stretch of time life's chemistry needs. Our sun sits in a remarkably fortunate middle ground. It is not so massive that it burns through its fuel too quickly, and it is not so violent that Earth's surface has to endure radiation storms every day. Astronomers have seen this more clearly as they study other star systems. Many red dwarfs, the most common stars in the galaxy, can live for an incredibly long time, but they are also known for outbursts strong enough to strip away planetary atmospheres. Stars heavier than the sun tend to live shorter, more unstable lives. Complex life does not show up instantly. It needs time to fail, adapt, and keep going. The sun gave Earth exactly what evolution needed, most time paired with stability. It is bright enough to keep water in liquid form, steady enough that the climate does not keep jerking out of range, and long-lived enough for oceans, atmosphere, and ecosystems to build up layer by layer. It still has flares, it still throws solar storms, and every now and then it still gives satellites and power engineers a reason to sweat. But compared with many other stars out there, Earth clearly ended up orbiting one that was patient enough to let life grow up instead of being cut off halfway through. Number 8. Earth does not just have water. It has liquid water that has stayed stable for billions of years. Water gets mentioned so often as a basic requirement for life that it almost sounds too obvious to matter. Everybody hears it, nods, and moves on. But the real point is not just that Earth has water. The real point is that Earth has a lot of it kept it in liquid form for an unbelievably long time, and built much of the planet's habitability around that one familiar substance as if it were part of the core design. Plenty of rocky worlds may have had water at some point. Some lost it early because their gravity was too weak or their atmosphere could not hold on to it. Others got cold enough that the water was locked away as ice. Earth did something different. It held onto deep, wide, stable oceans long enough for the chemistry of life to get started without being shut down too quickly. When scientists look back at Earth's geologic history, they see that after its extremely violent formation, the planet cooled down fast enough for water vapor to condense into oceans. And from that point on, the oceans did not just sit there to make the map look nice. Water absorbs heat slowly and releases it slowly, which makes it a massive climate shock absorber, softening temperature swings that early life would have had a hard time surviving. It also dissolves minerals, transports nutrients, and pulls molecules close enough together for chemical reactions to actually happen. Even ice behaves in a strangely helpful way. On Earth, ice floats, forming an insulating layer on top of the water and protecting what lies beneath from freezing solid. If ice sank instead, the oceans could freeze from the bottom up, and early life would have had a terrible start. Water here is not just present. It is involved in almost everything from climate and geology to the prebiotic chemistry that made life possible in the first place. Number 7. Earth's atmosphere feels like a built-in life support system. We are so used to breathing that we almost forget we are living at the bottom of an ocean of air. But if that layer of gas disappeared tomorrow, Earth would stop feeling comfortable very quickly. The blue sky is not just there to look pretty. It is a multi-layered system doing several jobs at once, and life depends on every one of them. It holds in just enough heat to keep the planet from freezing after sunset blocks. Most of the ultraviolet radiation, before it can damage living cells, burns up most small meteoroids before they ever reach the ground, and uses winds and pressure systems to move heat around the planet. What makes it stranger is that Earth's atmosphere does not just exist. Its composition is unusually well balanced. Nitrogen makes up most of it, helping keep the whole system stable. Oxygen is abundant enough to support complex organisms like us, but not so abundant that everything turns into a giant fire experiment. Carbon dioxide is the kind of molecule that makes people tense up the moment they hear its name, but in the right amount, it is part of the planet's thermostat. When scientists compare Earth to Mars and Venus, the contrast is hard to miss. One has an atmosphere too thin to hold heat and liquid water for long. The other has one so thick and aggressive that the surface is basically an oven. Earth sits in that rare middle ground. The atmosphere also does something even stranger. It does not just support life. Part of it is maintained by life. Free oxygen is highly reactive, so it usually does not stick around for long. And yet, on Earth it remains abundant because photosynthetic organisms keep pumping more of it into the system, which means this planet is not just hosting life. Life is quietly helping operate the very machine that keeps it alive. Number 6. Earth's magnetic field is an invisible shield that cannot afford to shut off. Some things save an entire planet every single day without making a sound. Earth's magnetic field is one of them. You do not see it when you step outside, you do not hear it when you look up at the sky, and most of the time we live as if it is not even there. But if that shield disappeared, Earth would change fast. The solar wind, those streams of charged particles pouring out from our star, would get a much cleaner shot at the atmosphere. Space radiation would reach the surface more easily, and this planet would slowly start losing the protection life needed to grow in relative peace. Scientists are not guessing about that. They can track the magnetic field, watch how it bends incoming charged particles from the sun, and when they compare Earth to Mars, the difference becomes pretty hard to ignore. Mars may once have looked more promising than it does now, but after its magnetic shield weakened, its atmosphere was gradually stripped away over time. Earth, by contrast, kept a molten iron core active long enough to power this system for billions of years. That sounds a little technical, but if that engine had shut down too early, life on the surface probably would have had a much rougher childhood. The magnetic field also does something else. It does not block all radiation, but it helps keep exposure low enough that DNA is not thrown into constant chaos. Evolution needs mutation, but not the kind where the universe seems to be rolling dice made of uranium. Early life needed time to make manageable mistakes, adapt, and slowly build towards something more complex. And through all of that, Earth did not just have oceans and atmosphere and the right distance from the sun. It also had a silent shield overhead doing its job every day without asking for credit. Number 5. Earth's gravity is almost suspiciously well balanced. Gravity sounds too basic to be suspicious. We are used to standing firmly on the ground, used to rain falling down instead of drifting back into the sky, used to the air staying wrapped around the planet instead of leaking into space. But the closer you look, the less that number feels like background detail. If Earth were smaller, its gravity would be weaker. The atmosphere would be easier for the solar wind to strip away, surface pressure would drop, and liquid water would have a much harder time lasting. Mars is already a pretty blunt reminder of what that version looks like. If Earth were much larger, the story would not get any friendlier. Stronger gravity would hold on to a thicker, heavier atmosphere, making breathing and temperature regulation harder for complex organisms. Life does not just exist under gravity. Life is shaped by gravity. Bones, muscles, circulation, posture, and the way blood moves through the body are all working within the exact pull Earth happens to provide. When scientists model rocky planets with different gravitational strengths, they keep running into the same problem: change the gravity enough, and many of the biological systems we take for granted would have to be redesigned from scratch. Gravity also quietly controls water and air in ways most people never think about. It is strong enough to keep the oceans here, but not so strong that surface pressure turns the planet into a crushing environment. It lets clouds form rainfall and the sky stay where it belongs. That sounds simple, but it is the kind of simplicity you only get when a lot of deeper conditions are lining up underneath. Earth does not just have gravity. It has the kind of gravity that lets a planet keep its water, keep its atmosphere, and still stay comfortable enough for complex life to stand up, walk around, and start wondering why everything feels so strangely well-tuned. Number 4. Earth's surface knows how to repair the system through plate tectonics. From a distance, Earth looks like a stable planet, but its crust has never really been still. Beneath our feet, tectonic plates are still sliding, colliding, pulling apart, and diving back down like a machine, quietly taking this planet apart and putting it back together at the same time. Mountains rise, oceans widen, continents shift, and Earth's surface keeps getting rewritten. The strange part is that this instability is one of the reasons the planet stays habitable. Plate tectonics works like a carbon recycling system. Volcanoes send carbon dioxide back into the atmosphere, while rocks and oceans gradually lock it away in minerals and pull it back down into the planet. The process is slow, but over millions of years it helps keep Earth's temperature from drifting too far to either extreme. When scientists compare Earth with Venus and Mars, the contrast becomes pretty clear. One world held onto too much heat, another lost too much of its internal activity. Earth somehow managed to avoid turning into either a furnace or a frozen shell. Plate tectonics also does something else life seems to love, even if earthquakes are not exactly getting 5-star reviews. It pulls minerals from deep below up to the surface, creating mountains, islands, coastlines, and all kinds of different landscapes. Every one of those changes opens up a new environment for life to experiment in. The more environments there are, the more ways evolution has to fail, adapt, and eventually figure something out. And this is not something every rocky planet gets. Many may cool too quickly, develop crusts that are too rigid, or lack enough water for plates to keep moving and reshaping the surface over long periods of time. Earth, meanwhile, stayed hot enough inside, wet enough on the surface, and flexible enough overall that the system never shut down. It did not just end up with a crust. It ended up with a crust that keeps stirring itself so the planet can stay alive. Number 3. The moon is unusually large, and it quietly helps keep Earth stable. If you stare at the night sky long enough, the moon can start to feel like Earth's accessory, like it is just there to give poets something to be sad about and tides something to do. But by astronomical standards, this satellite is unusually large compared to the planet it orbits, and that oddity turns out to be useful. The moon helps hold Earth's axial tilt within a relatively stable range, keeping it from swinging wildly into more extreme angles. Without that stabilizing pull, Earth's axis could wobble much more over time, dragging the climate along with it through mood swings that ecosystems would have a hard time surviving. When scientists model Earth's orbit and axial tilt, they keep finding that the moon plays a major role in keeping the seasons from turning into a climate roulette wheel. A planet whose polar regions sometimes tilt directly into the sun and other times sink into long, brutal cold would not be an ideal place for complex life to evolve step by step. On Earth, that stability gave living things time to adapt, spread, and build ecosystems around cycles they could actually count on. The moon also does something that seems gentle on the surface but reaches much deeper. It drives the tides. Tides stir nutrients through the oceans and create constantly changing coastal zones where the water rises and falls like the planet is breathing. Many scientists think environments like that may have given early life more chances to experiment, make mistakes, and eventually figure out how to move from water onto land. The moon's origin story is also strangely convenient. The leading theory says that early Earth was hit by a planet-sized body, and instead of being completely wrecked, That collision ended up leaving behind a moon large enough to do more good than harm. Number 2. Earth is not just habitable. It has survived one disaster after another. If you look back at this planet's history, the first impression is not peace. It looks more like a world that has been stress-tested over and over again. Asteroids slammed into it, supervolcanoes erupted, oceans shifted, the climate turned on a dime, and more than once life got knocked down so hard it looked like the whole game was over. But Earth has a strange habit. It takes brutal hits, leans right up to the edge, and somehow still does not break completely. Scientists piece that story together from rock layers, impact craters, volcanic ash, and the fossil record. They know there were mass extinctions that wiped out huge portions of life on this planet. The impact that ended the age of the dinosaurs is just the most famous headliner on that list. Before and after it, Earth went through other major crises. There were times when the oceans ran low on oxygen, times when the climate shifted hard, and times when volcanic eruptions became so intense that the sky itself practically turned into a global problem. On many other worlds, a few blows like that could have been enough to shatter the whole life support system beyond repair. But here life kept coming back. Not in perfect shape, but more like it came back limping and then kept evolving anyway. After each major hit, there were still enough oceans, enough atmosphere, enough active geology, and enough time for the surviving branches of life to start filling in the empty spaces again. Evolution on Earth did not happen in a carefully protected garden. It happened on a planet that occasionally smashed its own stage and then switched the lights back on so the show could keep going. That is what makes this part so unusual. Earth did not just start with good conditions. Those conditions were durable enough to take repeated planetary scale blows without crossing the point of no return. The oceans never boiled away for good. The atmosphere never fully collapsed. The magnetic field never stayed off long enough for everything to come apart. This system is not immortal, but it is stubborn in a way that gave life repeated chances to keep going long after it looked like the story should have ended. Number 1. None of these factors stands alone. They lock together like a living machine. This is where the story stops feeling like a list of lucky breaks and starts feeling like a system fitted together a little too perfectly for comfort. Earth does not just sit at the right distance from the sun. It also has the right kind of star one that does not roast the surface or leave it trapped in instability, the right amount of water to cool the climate and support the chemistry of life, the right atmosphere to hold in heat and block harmful radiation, the right magnetic field to protect that atmosphere from being stripped away by the solar wind, the right gravity to hold on to air and water without crushing complex life, the right plate tectonics to recycle carbon and minerals, the right moon to keep Earth's tilt from going off the rails, and enough time for all of those systems to keep working together. None of these factors works alone. Water needs an atmosphere if it is going to stick around. The atmosphere needs gravity to stay in place. The magnetic field helps keep that atmosphere from being worn away. Plate tectonics regulates carbon in the air, so the climate does not drift too far toward runaway heat or deep freeze. The moon helps stabilize Earth's tilt, so climate cycles do not swing too violently. And the sun provides steady energy long enough for all of those systems to coordinate with one another. Remove one link and the whole structure starts to weaken. Remove several and this planet might still exist, but it probably stops being the kind of place complex life would want to live. And the more exoplanets astronomers discover, the clearer that picture becomes. Some worlds sit at roughly the right distance but orbit stars that are too violent. Some may have water, but lack a stable atmosphere. Others may have an atmosphere but show no sign of a magnetic field strong enough to protect it. The farther we look, the less Earth feels like a planet that just happens to be decent in a few categories. It starts to look more like a chain of conditions locked together, each one helping the others keep going. And it is from that almost suspiciously precise coordination that life had enough time to go from molecules to oceans to forests, and eventually to a species that can look up and ask why this home fits it so uncannily well. And maybe that is the strangest part of all. Not because Earth is perfect in the sense that nothing bad ever happens here with no disasters, no chaos, and no moments where everything almost slips over the edge. But because after all of that, so many things are still working well enough all at the same time for life not only to appear, but to survive, evolve, and eventually sit here asking questions about the very planet that gave rise to it. In a universe full of worlds that are too hot, too cold, too violent, or too unstable, Earth just keeps standing there like an exception that is hard to explain. If one of these 10 reasons stood out to you the most, drop it in the comments below. For you, what is the most suspicious thing about Earth, its position, the moon, the magnetic field, or the way everything seems to lock together like a living machine? If you enjoy videos like this, make sure to like, subscribe, and turn on notifications so you do not miss the next one. The more we learn, the more it starts to feel like the home we live in may be far rarer than we ever imagined.